Hi, hello everyone, and welcome to this video. So last time we left off basically with our attenuation, which was a light fall off, and this time we're going to work on specular lighting. So what's a specular light? Well, it's this part of the light, right? We have here PONG, and specular are these like small dots, which just represent basically as your light hits some surface, some of that light is reflected away. And then you can see that reflection, and that's what this specular light actually represents. So here we're going to model it with a blind PONG reflection model. So I did a metal video. If you're just interested in PONG specular light, you can check that. They're very similar, only difference is here for the PONG only. We're using reflection vector, but here we're using half vector instead. So how that works, we're going to see now. There is this good explanation on Wikipedia, and I'm not going to go so much into details about this light. Rather, we're going to comment on it as we work on it. So we can get started. So in order to start, actually, I'm just going to explain actually quickly. So here. So basically how it works. Basically we have some light, and then as it hits surface, it's actually reflected away. This should be actually right angle, but it's reflected away, and then if you're looking here, right, maybe you're looking here towards some scene, and then your this will catch some of that light as well, basically your eye. So we have to model that eye. And I, as you can see here, is just a vector from the surface towards the eye. And what is I in this case? Well, we already had it. It's our camera position. So we're going to need to pass I to our shader. So we can start with that actually, and that's very easy in our shader. And maybe should I enlarge this a bit? I probably should. So let's try just to enlarge it a bit. So we had this, and we had this projection view. So this was information from our camera. So we can just continue here. So we're going to have another group, which is group 1. And then we have going to have binding 0. We need uniform and not the model. This is wrong suggestion. We have I, which is of type vector3 float. And we're going to need it actually in fragment shader. So we can just pass it in. We could have pasted directly to fragment shader as well, maybe. Well, I don't actually care, because here it makes sense. Since we're already passing the camera, we can just use that. And then we're just going to pass it to fragment shader. And here in fragment shader, we're already using this output. So that's it basically. So we just need to go to our camera class, which is somewhere here. And then we had buffer, which was for projection view matrix. Now we're just going to create a buffer for the eye. Maybe we could have packed everything into one buffer. To be honest, I don't care too much about it right now. So we're just going to create one. Let's get rid of this, and then this eye buffer. And we're passing this eye. Although it might complain about it because this is vector3 type and it needs to be 16 bytes aligned. We'll see. We'll see if it complains about that. So actually it does already. I don't see anything, and that's probably because this already failed here. So we had this thing where we could just pass in length, and so for float is of basically 4 bytes, right? And then we have 4 floats, so we're just going to pass 16. And then here, instead of this I, I'm going to do it like this maybe. We're going to pass new array here, because it already complains about this. No, it might complain because of our shader. So let's actually fix that first, and then we're going to get back to it, because I forgot about this. Here, not our pedal, in our, what was it, render pipeline. So we're going to need to make a couple of changes here. Somewhere where we use the camera material bind group. Is it fine here? I think it is. No, it's not. It was camera. Camera, where is it? Ah, here. All right. So for our projection view, and here we could rename it to camera view group layout. If you want, you can do that. I'm just going to reuse this because I'm very lazy. And then I'm going to just hit to do rename to camera view group layout. Very lazy, but it works. Then here we had projection view bind group, and here do rename to camera view bind group. So here second entry, we have to define second entry, and we can just use this. This is binding 1, and then this is I buffer. Cool, it works. So now let's get back to our camera. We have that buffer, then we just need to pass data to that buffer, and I think it actually just passing this I might be fine. Right? No, maybe. Well, we can check it. We can check it if values are all right. It should be something that's like 0, 0, minus 20. I believe. Will you catch it? Let's see our buffers. So we're interested in camera I buffer right here, and it's 0, 0, minus 20, and then 0, because our camera was at position minus 20. So that's perfect. We already solved this part. So now we can actually solve for the part where we actually do the specular light. So here we're just going to start in shader because that's going to be easiest way. And we can define some of this stuff, right? So do I have a formula here somewhere? No. No, I don't have, but it's very easy, right? Here it says normal.h, and then we just need to find this half vector, do a normal with it, and then it's very similar to directional light. So it's going to be very similar to this, sorry, not directional, diffuse light. So we have diffuse light, and then what I'm going to do here is just say specular light, and it's very similar. So right now I'm just going to hardcode this, but we're going to have again intensity and color. So I'm going to say this var specular intensity, and I'm just going to do 16 so that it's easier to see, and then it's a float type. I guess this should work probably. Then we're going to have specular color, and that's quite alright. White is alright as well. And then so here we already have this normal, that's good. So we need this half vector and half vector, right? So basically we need let's just clear it up so that I can explain it. So we're not doing this, this is in PONG, so we need this view vector, we already have it, we need this vector, and we need this half vector, and to get the half vector we need light vector as well. So what's the half vector? Well, it's just this vector, which is view, and then plus light vector, as it says here, right? So light vector plus basically view vector, or our I. So we're going to have to find the view I vector, and then just normalize this. All right, let's do it. So I vector, I'm actually going to call it towards the I. I think it's a bit more better description. So vector towards the I, and that's exactly this vector, right? And why does that work, right? We had this I, so this is position of our camera sum, and then we had fragment position. So here, all right, so we had I, right, which is our camera, then we we're looking at our cube, maybe at some fragment. So how do we find that vector? Well, we just take the I, right? And then minus this one, right? And we get basically this vector, and then we just normalize it. Okay, good, we have that vector. We can find half vector somewhere here. So var half vector, and it already offered me solution, so it's our light direction, which we have, right? And then also the vector towards the eye. We do dot, and this is probably a good suggestion. So we do dot, and similar to last time, we actually just have to clamp it between the 0 and 1. And I actually believe that I forgot this in last metal video, so I'm going to have to fix that, but alright. Then, yeah, I haven't mentioned this, it's already suggesting it, but basically when you get this specular amount, we actually, so let's say this is our specular amount, and we do some exponent on it. Let's say this is specular, and then we do some exponent on it. And what does it do? It's basically kind of models shininess of material. So we're actually going to do this step a bit later, and I'm going to do it like this, so that I can comment it out, and then we can see how it works. But then, similar to this diffuse light, we just add everything together. And let's see if this works. It doesn't work, interestingly enough, but let's see what is it complaining about. No. Do I need to add 0? I need to add 0. Okay, be careful about this one, as usual. And now nothing is working, which is super weird. So let's comment this out as well. Alright, I guess our specular intensity is way too high. So yeah, that won't work. Okay, cool. So we can leave it at this here, and then we can play with this shininess, specular intensity. And so it's here, it's not specular intensity, it's rather it's some constant, which we're going to call here shininess. And I'm going to set it to some really large value actually. Let's do this. So here it's a bit difficult to see shininess. We're going to have to play with it a bit later, so it might be easier to explain a bit later once we do it for our point lights. So let's do actually point lights as well. That's going to be very easy. We just need to recalc this half vector. So here I'm just going to say specular light for our point lights. So we just need that, and then this is basically the same, if I'm correct. That's specular light amount. Okay, we did something wrong, but that's quite alright. So I cannot have bar here, I cannot have bar here again. Probably, let's see what it is. Specular intensity, here it's complaining about some, oh wow, nasty typo. Okay, cool. Cool, you can see here specularity of this light, and that's because our light as our camera is positioned somewhere over here, let's say, and it's looking towards the scene, and then there is a cube, and the light is right above here, and then there is this surface. So basically the specular light, we're going to have to move the light a bit so that these regions are a bit more well, just for them to look better. But now we can play with this specular light, so we can say 32. As you can see, the light is scattered, but if you increase specular intensity, oh wow, not that much, please. We're going to go blind here, but as you can see, this specular intensity models this. So now what I want to do is just to move camera maybe a bit, so that we can see this bit better. I'm just going to move it maybe 5 units somewhere, maybe 10. Okay, it's still reflecting, doesn't look that good because it's a bit hard. Okay, this is better. Now you can see how here, how kind of dispersed it is, and that's modeled a bit better. It's kind of difficult, like to basically get this right, but there is another way, which is probably good as well. Maybe let's try to model this. Okay, anyway, we can see it. We can see it, and if I try to do, let's go to our pedal. So please don't do this. I'm just going to showcase it. Maybe a bit larger. 10, 10, 15, 15. Okay, you can see this speckle light, how it's reflecting off the cube, and basically what it's a bit difficult to showcase, so I'm just going to say play with it. All right. So, but now what I want to have is actually specular light per. So we don't want to leave this constant. So we want to do it for the point light, for the direction light. So let's do that. So we can start with directional lights. So it's going to be very easy. Here we already had directional light. So I'm just going to expand that directional light, because why not? So here we can say specular color. And then we can say specular intensity. So we're going to leave this because we still need it for point lights, but for the directional light, which is actually here, and it is called directional light, so we're just going to paste it here, paste it not here, but actually here, and that's good. So we have to expand this buffer a bit. It's too small now, so basically we're going to have here this specular. We can just continue here. But I need to add specular light public, specular color is of type color, and can also be white by default. And then we have specular intensity. So this specular color.x or either .red. And then here last float can just be 0. That's quite alright. We just need to expand this a bit and it works. Cool. So we now solved it for the directional light. So let's solve it for the point light. Very similar. We're just going to expand it a bit. So here we can say public specular color, score.white. Specular intensity is 1, and then here, a bit difficult to see, but we're going to have this specular color.r, then we're going to have specular color.g, and then in new row b, and then we have two floats which are left, and we also need to expand this data from 12 bytes to 16 as well. Right, because what happened is, right, we had 12 bytes reserved, but we need to expand the data a bit with 4 bytes, so now we have 16. Why? Because we need to be 16 bytes aligned, right, or 4 bytes aligned. I don't even know anymore, but it's just because of the alignment. And then in our material shader, so we're going to expand here. So we're just going to say location 6, specular color, and then specular intensity. And now it works. And so if we modeled everything correctly, we're not going to need this anymore. And here, now it's breaking, but that's quite alright. So we're going to say this positional lights I, that specular color, and then that specular intensity. Cool. So just to test it out, so let's just use one of the lights and ramp up that specular intensity to 15. doesn't work. Okay, that's interesting. Actually, so something went wrong. Very weird. Alright, let's see. Specular color is color.red. Alright, let's see. I did something wrong because this is not working. Specular intensity, that's quite alright. Is this light direction good? It needs to go towards the light, and it does. So light direction here is good. But it actually worked previously, so it must be something just with the buffer. So let's just check these point lights. Maybe I did something wrong here, probably. So we hit color.light, we paste in specular intensity, color intensity. I did expand it, and in our shader this actually should be good. I'll have to double check it. Alright, sorry, I managed to do it. It seems something was messing with the point light. So but basically something with alignment. It seems like vector 3 cannot be used with some weird offset. Anyway, it was pretty easy to fix it. So I added this at location 6 and then moved specular color and specular intensity up one location. So here we just have a vector 2f, and then I use this discard so that we know that we're not using it. And then in our point light, I moved this specular color to last position. So here, for that discard, I placed 2 zeros, and then I placed here specular light, and then finally specular intensity as well. So I think I should probably do the same thing for directional light, and here we can see the effect, right, of this 16 intensity. I should probably do same then for directional light, so let's just check it here as well. Maybe I should do that actually. So here I'm actually going to place 0, and then I'm going to place this specular color here, and then move this final 0 out of the way, and then you can see it has already changed the matte here. So let's do that in material shader as well, direction light. So where did I place it? Here we're just going to add location 3 discard, and it's not vector 2f, it's already f32, and then here it's 4 5. Sometimes you have to do that, like it depends on shader language really, and then the layouting setup. It's really annoying because this is usually not the issue with GLSL shader, might not be issue with high level shader language which you use for DirectX, it might. So yeah, sometimes you have to mess with stuff like that. Cool. So we already solved that, so let's just play with our shininess. So let's see what happens if I increase it. As you can see, the light of mount is smaller, but actually more concentrated. So here, and then maybe 300, 5000, very small but very concentrated, so we can play with the shininess. And for the shininess, we're actually not going to do it like that, of course. We are going to pass it in somewhere. Here it can just be, because it's another property of material, we're just going to do it at binding 3 shininess, and it's of type f32. And then, as usual, the annoying part, we have to do everything in our render pipeline. So we added this shininess. It's very similar to diffuse color, so I'm just going to copy paste this lazily, and then we're going to have new uniform buffer for shininess. Let's buffer. This is going to be called shininess, and it's of type number, so I'm just going to set it maybe like 32. That's a good value. And then shininess, so shininess is equal to value, which is of type number, of course, and shininess buffer update. and then we cannot just paste it like that, we have to actually pack it. So here I'm just going to paste it like so, very simple. And then we probably have to create this buffer. So let's see, we can create here this shininess buffer, new uniform buffer. Alright, that's quite good suggestion here. And then we just have to modify this layout. This is vertex group layout, not material. So here we're just going to paste another buffer, but at binding tree. And then we have to find that bind group, not the vertex, not the projection, not the lights, material bind group. So here, very similar to this one, it's a binding tree, and then the buffer must be shiny as buffer. If I save it, it works. So we can check it. Let's go to our pedal and let's mess with this shininess value somewhere here. So we can just say this pipeline. Come on. Shininess is 0.2. Okay, it works. So if it's a 1, if it's 16, we can already see that it works. Okay, cool. So basically that's it for this video. So just to recap quickly, it was very easy to find specular light, right, if you agree with me. So what did we need? Let's just recap this quickly. So we didn't need this reflection vector because what we were doing is blend PONG instead of just PONG. So it uses half vector and then the view, and we just do the dot product of basically this half vector and the normal vector, right, which gives us our light amount. And the half vector, we just find it as a sum of view vector and light vector. So we get this, right? This is the half vector. We do dot product of normal and half vector, and that's our light. And then as usual, we have the specular intensity, which is just a constant with which you can make it larger, smaller, right value. We had color, which is, well, basically it's a color. And then we had as well this shininess, which is actually it's described here as well, since PONG is using, right here, shininess exponent can be blah blah blah, such that this dot product is, and then we have this exponent shininess. Cool. That's it for this video. Next time we're going to do shadows. So if you like it, please like, subscribe, maybe leave a comment, and until next time.